Hello again, Algebra 2. Back to Chapter 7.3. As I said previously, this is a rich chapter that deserves two separate lessons, and so in fact, here's that second video. It's on a particular type of function operation, and just one type, but a particularly important type called composition. Essentially, what you're doing in composition is you're putting one function inside another function. Now, I don't know how helpful the green box from the textbook is going to be to you in this case. I've copied it here just to remind you to give it a glance, but I'm going to explain it a different way than the textbook does. I do need to make one point here that I might otherwise forget to make. Don't make the assumption that putting one inside the other is the same as putting the other inside the one. In other words, f of g of x is generally not going to be the same thing as g of f of x. Let's not talk about it in the abstract. Let's talk about real examples here. Let's say you got a coat sale. And let's say that the sale is that you get to take $50 off the cost of any coat in the store. Let's say they are also offering you, and you've probably been to department stores that do this, they're also offering you 10% off your entire purchase if you open a charge card. So there are two different ways to save. And one of these ways is going to go inside and come before the other. So I'm not going to walk you through how to solve this problem. This is something that we're going to work toward over the course of the next day or two. But question 54 in your textbook asks you to use composition of functions to figure out the sale price of the coat. And then it asks you, and this is an interesting question, to think about, why doesn't the store apply the 10% discount first before subtracting the $50? As I said on a previous slide back here, generally putting one first is not the same as putting the other first. And so you got to do some careful and critical thinking when you are doing composition of functions to make sure you're putting the correct one first. Let's talk about a how-to. How do you apply this skill of composition of functions? Let's say you're trying to do f of g of x, and that's actually how you tend to say it. The g of x, the function g, is inside and going to come before the f function. Well, let's say you've got these as your two functions. F is 3 times x to the minus 1 power. Remember that minus 1 means x is on the wrong side of the dividing line. The g function says 2x minus 1. So to put g inside f, I see it from the outside in. In a minute I'm going to show you the textbook's way. They look at it the opposite way I do. But I see it as, look at the outside one first. We've said that f is going to be that outside one. And in place of x, wherever x or whatever the variable is, in place of that variable, put a nice wide set of parentheses because you're going to end up filling that in. So this 3 times x to the minus 1 becomes 3 times parentheses to the minus 1. And you fill that in with the other function, with the g of x. So now notice I'm doing 2x minus 1 to the minus 1 power. Well, like I said before, that means that this is on the wrong side of the dividing line. It just means you're now multiplying 3 times 1 over 2x to the minus 1. Now notice, it's 2x minus 1. This is a little confusing as an example because I've got minus 1 and to the minus 1 power. Don't get lost in that. But I did want to note, now that I've got it on the correct side of the dividing line, all I am doing from now on with this exponent is saying it's to the first power. I could get rid of that. So cleaning it up, I actually have 3 over 2x minus 1. That is the result of putting g inside f. Let's look at it the opposite way. What would happen if I put f inside g? Well, again, I'm going to look at the outer function first. G is my outer function this time, and instead of the variable, I'm going to put parens. So I've got 2 times parens minus 1. In those parens, I put the other function, 3x to the minus 1. Again, remember that minus 1 says that x is on the wrong side of the dividing line, so let's clean that up and make it 2 times 3 over x minus 1. Now distribute the 2, and you're going to end up with 6 over x minus 1. And that is the composition g of f of x. The textbook in example 3 gives you exactly those two that I just walked you through, but as I said, it looks at it a slightly different way. So I'll go ahead and show you what they've said. They do end up with the same answer, but they don't write it out the same way. If you want to read what the textbook says for example A within example 3, by all means do, and see how they say it a little bit differently. And here's B. Again, they end up with the same answer that I do, but they look at it slightly differently. But I want to call your attention to C. Notice you could do f of x. You could do a function, a formula, in other words, and then apply the rules again a second time. So, well, if f of x is 3 times x to the minus 1, then f of x is going to be 3 parens to the minus 1, and inside those parens, you're just going to put this all over again. So it's going to be 3, well, I'll show you. It's going to be 3 times 3x to the minus 1 to the minus 1. And if you carry that through, you're going to find that that turns out to be x. Work that out if you need to. Hit the pause button and make sure you understand how this became x. I'm not going to talk this whole example through. Instead, I'm going to assume that you paused if you needed to. I'm going to focus on the other thing the textbook mentions, because this is a critical point. They talk about domain. That first example, f of g of x. You can use any value for x except 1/2. Why? Well, look back here. If I had used 1/2 here, 2 times 1/2 is 1. 1 minus 1 is 0. You can't divide by 0. So anytime that your function calls for division, be careful to make sure you've thought about what would make it undefined, what would make you divide by 0, and you can't use that x value. Similarly, for g of f of x, and for that matter for f of x, you can use any real number except 0. Why? Well, look, here you're dividing by x. Can't divide by 0. And here, where was it? Oh, x to the minus 1. Well, x to the minus 1 means 1 over x. Again, it would be dividing by 0. Can't do that. So that's why you can't do those. Now, you'll notice that in the example C here, f of x, in the end, you got down to just x. And you might think, well, I could put anything in here. But you have to look each step of the way and see if there's any point where you would get an undefined answer or an imaginary answer. If either of those happens, undefined or imaginary, that's a case where you can't, where x is restricted, where the domain is restricted. So, like the previous video, I'm not going to have you worry about the domain for these problems. Just focus on answering as best you can 13 and 14. Do both f outside, f of g of x in other words, and g of f of x for 13 as well as for 14. You might be pausing and working for a while before you get the answers to these, but when you come back, I'll show you the answers for 13 and 14. Okay, I'm going to assume that you paused, worked 13 through and 14 through. I'm just, in the interest of time, I'm just going to show you the answers. F on the outside, in other words, f of g of x, gives you 6x plus 3. G on the outside gives you 6x plus 1. Notice, once again, the answers aren't exactly the same. For 14, f on the outside gives you this trinomial, and g on the outside gives you this binomial. I am happy to explain either of these two problems, 13 or 14, if you bring in questions, but I'm not going to talk them all the way through in the video. And that, as a matter of fact, is the extent of this video lesson. So I know that this is a complicated concept. It takes a while to wrap your arms around it, but bring in any questions that you have, and I'll be happy to talk those through.